The next module we will be implementing is booking microservices. So we have covered the flight service which will create the flights. Then we have seen the flight search service. So whenever the user is requesting for a flight in the flight application, based on certain criteria, the list of flights are available. Out of these flights, now let's say the user want to do booking on a specific flight. So here the booking service will come into the picture. So we will implement this booking service, and for storing these details we are using the MySQL database. Now the booking service will interact with the flight service to check for the seat availability, and it will reserve the seat on the flight. So the communication between the booking service and flight service, we will use the synchronous communication. Subsequently, the booking service will communicate synchronously with the payment service to do the process payments. And after a successful booking, the notification service is triggered to send the email notification. We will implement the notification service using a asynchronous communication approach, employing the event-driven architecture with Kafka. For synchronous communication between microservices, we can implement it using various approaches such as HTTP exchange, FAN client, and web client. So inside this spring.io website, we will define the booking service microservices. For this, we will use Maven as a project, Java for language, and 3.8 as a Spring Boot version. The group ID, similarly, we will define com.techword. Artifact ID is booking service, and the description is booking service for flight system. Now let's see the packaging also. So packaging is jar, and the baseline version is 17, as we have already seen. For Spring 3.0, the minimum version is Java 17. Now let's configure some dependencies. So we will add web dependency, we will add the Lombok dependency, and we are using MySQL, so we will use Spring Data and MySQL driver. For time being, we will add these dependencies only, and later on we will add few more dependencies. So now click on the generate. It will take a while, and now this folder is ready. So copy this folder and copy this in your flight booking system. Now in the Visual Studio Code, we can see the booking service is ready. So let's quickly configure this application, and we have to add here in the resources this application.property file some values. So these are the same property we are adding what we have added in the flight service module. So we will make sure that instead of flight DB, we will use here booking DB. Rest other details are same. Now let's implement this 3-layer architecture: controller, server, and persistent layer for this booking system. Once you are trying to book a flight, you have noticed something more, right? Along with booking a flight, they will provide you some other features, like you can book a hotel and you can rent a car. In our booking services, we will show you one example where we can see how we can call the booking services for flight system, but along with that, at high level, I will show you like how can parallelly you can configure this booking service to behave generally, so that you can integrate any of the features, like you can book a hotel or you want to do a rental of the car. So in our example, we will see with the help of seal classes provided in Java, which will provide a better control for inheritance hierarchy. So this is our booking service, right? So inside this booking service, inside this Java, we will create some packages: the controller package, entity, model, repository, and service, as we have seen previously. So let's first start by understanding from the model perspective. So for booking a service, first we will see what all parameters we need as part of booking. So first is the booking request. So inside this booking request, we have made this class as a seal class. Seal classes are new feature introduced in Java 15 as a preview feature, and it became a standard feature starting from Java 16. Sealed classes are used to restrict the inheritance hierarchy of a class, allowing you to define a limited set of subclasses that can extend it. To create a sealed class, you need to use a seal modifier before the class keyword. Additionally, you need to specify which subclasses are allowed to extend the sealed classes using the permits keyword. So we will define this identifier seal before the class. And we have to use one more thing called as permits. So inside the permits we will restrict like which all classes we want booking requests to be used in the hierarchy. So flight booking system is one class and hotel booking request is another class which will be extending this booking request. And here we will define some properties like passenger name, amount and the payment mode. So either you go for flight booking or you go for hotel booking, you need minimum of this information like for which passenger you want to do the booking and what is the mode of payment. Next we will see the flight booking request. So for the flight booking request, I have only defined a property called as flight number. The reason behind that is like I have not defined another details like what is the origin, what is the destination, on which travel date it is traveling, because this information we are trying to retrieve from the flight service what we have defined. So in the later part of this video I will explain how we will communicate with different microservices. So for this reason only flight number is enough information. So once we pass the flight number we can get the entire detail. So this is how we can implement the flight booking request. As you have noticed, once we are defining this class which is extending this booking request, the final keyword is important because you cannot extend one more time this flight booking request. So this is the usage of seal classes. Similarly for hotel booking request also you have to make sure that you have to use the final keyword and it is extending the booking request to make sure that this cannot be again inherited. So here we can define some additional details like hotel name, check-in date and check-out date. I have provided these details in more informative because we are not providing any of the microservices usage for this implementation. This purpose is only for telling you the understanding of what are the seal classes and how we can use the seal classes. So now we have understood the basic usage of the booking request, like how we can make a booking request, either it's a flight booking request or a hotel booking request. Now apart from that thing, now we need to persist this detail. So as part of booking we will store this information like this is a hotel booking request or it is a flight booking request. Okay, so let's see now the persistence usage. So let's go to the booking class. Inside this booking class we are using the annotation as entity. Then we have a data annotation to generate the getter and setter. No are constructor for default constructor, all are constructor for all argument constructor. The table annotation, if we are adding the table annotation we can customize the table name. So here as you notice I am providing the name as bookings. In case if we are not using the table annotation, by default the entity will be generated with the name of the class, that is the booking. And here I have defined some additional parameters like inheritance and discriminator column. Let's say we want to store the entire information about the different booking types, like either it is a hotel booking, it is a flight booking or it is a car rental kind of booking. We want to make sure that everything we can categorize in one table. So as part of this we will use the concept of inheritance annotation. This will help us to provide such values in a single database table. We have specified the Java annotation called as inheritance to specify the inheritance strategy for booking class. Now inside this we have defined the strategy as inheritance type dot single table. That is one of the strategies supported in Java's JPA for mapping inheritance to the relational database. In this strategy, all the subclasses of booking are mapped to a single database table. The table will contain column for all the properties for booking class and its subclasses. we can use something called as discriminator column. If we are not using this annotation, by default the Spring JPA will provide us a facility to include one column called as D type, and it will store its information in the string format with its default name like hotels or whatever. But if we are using the discriminator column, we have a flexibility to define our own customized column. Instead of D type, we can go with a specific name like booking type and what kind of format we want to use. So we want to use here the discriminator type as discriminator type dot string. This will help us in the context of JPA for inheritance mapping. So this also will help us to determine the type of row, indicating which subclass it belongs to, as I mentioned. I hope it is clear now. Now let's move on to the properties. So as part of this, we have defined the unique identifier for this table, that is the primary key for our application. So that is private long ID, and we will annotate this with the annotation ID. So this is very important. If you are defining any entity, you have to make sure that there is one @ID attribute should be there. If it is not there, you will get the compilation errors. And then we have a generated value. Here we can define the strategy. So we are using the strategy as generation type dot identity. Next we need the booking number. So this booking number is the value which we will be generating. This is a unique identifier which we want for our booking system to refer in future references. Then we have the passenger name which we will get from the booking request. And then there is something called as status. So there can be different types of booking status. For example, created, confirm and cancel. Initially the status will be in created state. Once the payment is done, every processing is done, then it will be in the confirm state. And then if there is some error due to some of the reason, it may go to the cancel state, and so on. We can even create several other state information. For time being, I have provided this three information. Then we have this amount. So this amount also is coming from the booking request and the payment mode. Finally is the booking date. So booking date will be the time stamp, the time we are creating this reference number. So this also will be processed by booking system. So I hope now at high level you have understood what is booking class and how we can use it to store different value. Now let's go to the flight booking class. So this is some additional information we want to store in the booking table. So here you can see the discriminator value we have provided as flight, and the flight booking class, as we have seen, only we are using the flight number. So I have just provided this information. We can add additional information as well. So for hotel, we have a discriminator value as hotel, and rest of the details are same what we have seen in the hotel request: the hotel name, check-in date and the checkout date. And this also has an entity with no R constructor and all R constructor. So here you will notice, instead of creating a separate entity as hotel booking, it will create only one entity called as booking, and inside the booking we have a discriminator column with booking type. So inside this booking type, once the request is coming for hotel booking, it will annotate this with hotel and the entire record will be stored. Now we will see the booking response. The booking response is quite similar to booking with some details here and there. We ideally need this booking response so that we can communicate between different layers, from the controller layer to the business layer to the persistent layer. So now let's see the usage of booking response. So for our functionality to show the use case of sealed classes, again I have made this booking response as the usage of sealed. So we are using the sealed, and here we are permitting it for flight booking response and hotel booking response. And as you can see, all these details are similar to what we are using in the booking class. The next is the flight booking response. So for the flight booking response, it is again same as a flight booking class. Only difference is we are using this as a final keyword, and we are trying to make sure that it is extending from the booking response. to show the seal class functionality. Similarly, we can see the hotel booking response. So for hotel booking response, we need these 3 parameters, and we have to make sure this will use the final keyword and it should extend from the booking response. Now the booking request and booking response are in place. Let's see the controller and service and the repository usage for this implementation. So we will first define one package called as controller, and inside this controller let's define this class booking controller.java. And for this booking controller.class we will use the annotation called as rest controller to annotate this as a controller, and we will define the request mapping here. So we are using the version 1/API and bookings. Log4j2 we are using for logging. As now we understood what is booking request, and what is booking response, and how we are using this for the generic purpose, and how we are using the specific implementation for hotel booking and flight booking. Now let's see the similar kind of implementation for the service usage. So inside the service package, we will define one interface called as booking service. This booking service is responsible for creating the booking. So it will take the generic value called as booking request, and it will return the booking response. Now we want to define our own specific implementation for hotel booking service, flight booking service, and car rental service, right? So in our use case, we will only be going with the flight booking service and the hotel booking service. Let's define the flight booking service. So flight booking service.java, it is a class which is implementing this booking service interface. So for this interface, we have to override this method called as create booking, which will take the booking request as an input parameter, and it will return a generic booking response. So what all things we will do here? Let's see. So first we will define this as an annotation for service to create a bean for this class. Then we will define the requirement argument constructor. So here we want to invoke the repository, so we need this parameter, and this qualifier I will come later what is the importance of this qualifier. So as you have noticed, we are using the specific repository to store this detail like flight booking repository, hotel booking repository. If you want, we can even make this as a generic by providing only the booking repository, and then we can provide some more information to save the specific sorts of data. But for simplicity, I have used the different repository layers. So first let me go through this repository layer. So inside this repository layer, if you see, we have defined this flight booking repository.java, which is an interface. So this interface is extending the JPA repository, and for this JPA repository we have to define the entity which we want to persist along with the primary key for this class. So if you notice here inside this flight booking, we have a primary key which is ID. You will be surprised, right? Here inside this flight booking, I do not have defined any ID parameter, but this is using it from the booking table. So inside the booking table, we already have defined this as a long parameter. So it will be taking this value. So moving back to the flight booking repository, here we have just annotated this with JPA repository. So it will allow us all the CRUD operations like save the record, find all records, get the first record, and so on based on the ID. And one important point, if you have noticed here, is I am not using the repository annotation here to create the flight booking repository bean. This is why, because from Spring 3.0 onward, for writing the repository annotation is not mandatory. We can skip the repository annotation and it will generate the repository bean accordingly. I hope now we have understood what is flight booking repository. Let's move on to our flight booking service. So for this flight booking service, now we understood this concept. So as we are using this requirement arc constructor, we are trying to use this from the constructor perspective. We have to use the final keyword. If you are trying to write the auto wire, in that case you do not have to write this final keyword. Ideally, we have both the approaches. Either we can go with the auto wire option to invoke the repository, or we can use the requirement arc constructor.
Generally, providing this required arc constructor or writing a constructor will be a best practice, because in such scenario, as it needs the final keyword, it means we cannot modify this class, or nobody can accidentally modify this class. So this is a good use case to go with the constructor annotation for invocation of any beans. Now let's see the functionality for this create booking. As we have a generic entity booking request, first we will try to see, does this is an instance of flight booking request? If it is not there, you can throw the exception, illegal argument exception, that it is an invalid booking type, or you can specify your own custom message. So once we know that this is an instance of flight booking request, then only we will do the required functionality to develop our logic. So the next step is, once we are sure that this is a flight booking request instance, we will try to map the booking request to the flight booking request, and we will create the flight booking object so that we will process this flight booking entity. So this is a private method I have defined. As you can see, this is a private method which is returning the flight booking instance, and it is accepting the argument as booking request. So first step is, if you see here, we are creating the flight booking request from this booking request object by typecasting it to the flight booking request. Once this request is ready with us, we will be creating the instance of flight booking, and inside this flight booking we are setting the required details like the booking number. As I have told you that this is a unique value we need to create for each booking, so there is a concept of UUID. We will use UUID.randomuuid.toString. Then this is a flight number what we are receiving from the flight booking request. Booking date is the now date, so we can use the local date utility to create the now time, today's time. Then we have a passenger name, so this also we will be receiving from the flight booking request, the amount we will be receiving, and the mode of payment. For setting this payment mode, you have noticed that along with get payment node we are using the name method. This is what we are using because we are using the enum. So let me show you quickly the use case. So if you see here inside this flight booking, we are using this booking class, and here we are defining the payment mode to store the value as a string. But if you see the booking request, inside the booking request we are using the payment mode. So this payment mode is a enum, and this enum will have different values like cash, PayPal, debit card, credit card, Apple Pay. Now coming back again to our flight booking service. So once this payment information is done, similarly we will store the status. So for status also we are using the enum value. So we are using booking status.created.name. Okay, I hope this is understood now, how we can use enum to store the values as a string and so on. Now we will return this flight booking object. So once this flight booking object is written, once you have this flight booking object, if you wish you can do some more validation for flight booking. For time being I have not added any validation logic for the flight booking. The next step is we want to save this flight booking. So we will use this flight booking repository.save method to store this value of flight booking. And once we have stored this value, we want to create the response. So from this flight booking object, we will create the flight booking response using the beanutils.copy properties. This copy properties we have to provide the source and the destination. So the source object is the flight booking which has the entire detail, and we want to store this value in the flight booking response. So this flight booking response will consume the values from flight booking. As I mentioned previously that flight booking and flight booking response are replicating the same values, so it is quite easier for us to use this beanutils.copy properties method to directly copy the values. How simple it is, right? Within 2 lines of code we have entirely copied the object from flight booking to flight booking response. And finally we are returning the flight booking response. Have you noticed something? Here we are not doing any customization. We are directly returning the flight booking response instance because of the booking request. Okay. So booking response is a generic entity. We do not have to typecast again from the flight booking response to the booking response. This will be already taken care by the inheritance hierarchy. I hope now you understood how the flight booking service is working, the create booking functionality. Now let's move on to the hotel booking service. So for hotel booking service also we will do the similar approach. So first here we will define this annotation as a service annotation, and we are adding this qualifier. This qualifier is very important because from the one interface we are trying to implement the different services, right? So we will see later like how we are getting the exceptions if we are not defining this qualifier. Now let's see the hotel booking service class. So it's implementing the booking service, and here we are using the hotel booking repository. Hotel booking repository is very simple. Here we are just extending this from JPA repository, and it will persist the data of hotel booking with the primary ID as long, as we have seen in case of flight booking. So hotel booking, if you notice here we do not have any primary key. The primary key is associated with the booking table. So with the booking table we will able to see one new column called as booking type. Inside that booking type we can see this fields. Now let's again move back to our class hotel booking service. So inside this hotel booking service, first we will see the booking request. So we will check first this booking request is an instance of hotel booking request or not. If it is not, then we will throw the illegal argument exception. Now assume it is a kind of hotel booking request, then we will provide a mapping to create the hotel booking object from this booking request. So let's see quickly. It is quite similar to the flight booking service we have seen. So here also, like first we will create the instance of hotel booking request, which will be getting the values from the booking request, and then we will create the hotel booking object by providing the default setting values for this one, and then we will be returning the hotel booking. So once we have this hotel booking, if you want you can add some additional logic for doing the validation of hotel booking. I am not doing it for this tutorial. The next is storing this detail. So we will use hotel booking repository.save to persist this entity, and once this entity is persisted we want the hotel booking response to be sent back. So we will use the beanutil.copy properties file, and we will copy from hotel booking to hotel booking response, and we will return this hotel booking response. So booking response is a generic entity, so it will definitely take the inheritance hierarchy and it will accept this parameter hotel booking response. I hope now you understood very clearly like how we have implemented the booking service interfaces and how we are using different class implementation like hotel booking service and the flight booking service to provide the different implementation for booking services. So final step is the booking controller now. So let's go to the controller package, and here define one class called as booking controller.java. So inside this booking controller.java we will annotate this class with rest controller to make this as a API call, and for this API we want some specific URL, so we will provide the request mapping. So inside the request mapping we are providing this value /v1 is for version 1 API and bookings. Okay, then log4j2 is the utility what we are using. This will help us to provide the logs. Now apart from this, if you notice here we have defined this booking service interface, right? So we have two approaches. The first approach is like we can define this booking service with the booking service object. If you do so, here the issue will arise from the understanding perspective, like which booking service needs to be called, hotel booking service or flight booking service, right? So in such scenario we have to provide this by using the qualifier annotation. So this is the parameterized constructor. So this parameterized constructor will take the value for this booking service and hotel booking service, right? So here if you notice, we are using this annotation for booking service to tell them this is a qualifier for flight booking service. So it will search for flight booking service and it will invoke the flight booking service utility for the further functionalities, like we want to do the create booking, right? And if you see here, the second one, we have defined directly the instance using hotel booking service, what we have given here in the hotel booking service class. So if you see here, we have already annotated this with the qualifier hotel booking service, and for flight booking service we have provided this annotation flight booking service. So the same annotation I have used here in booking controller. So for creating the instance, I am using the same variable name, and for a generic thing if we are using in the qualifier, we have to provide this qualifier annotation which we have seen, right? So I hope now you understand the difference between how we can use the use of qualifier and how we can directly access hotel booking service without providing any ambiguity to the booking services. So these are the two different approaches which we can use. And the next one is the now the controller. So we are creating the controller for the flight, and we want to use the post mapping. So here we have defined one method called as create flight booking, which will be taking the request body as flight booking request, and it is returning a generic response called as booking response. If we want, here directly we can provide the flight booking response also. And here inside this thing I have just added one log statement which will provide us the information about the flight number, and then we are invoking the booking service dot create booking. So this will invoke the flight booking service because of this notation, because of this annotation qualifier with the name mapping flight booking service. Similarly, we will provide another controller API for hotel. So for this hotel API, we have provided the same way like we have seen in the flight. It is using the post mapping, and the name is create hotel booking. It will also take the request body as hotel booking request, and we are logging this information about the hotel name, and then this hotel booking service will give a call for create booking, and this create booking internally will return the booking response as an object. With this, our functionality is ready to test. Let us review one more time what all things we have implemented. So let's first start with the booking controller. Inside the booking controller, we have provided a API for flight, which internally is calling the booking service of flight, and we are calling the create booking method. So inside this create booking method, if we see, we are first checking for the validation this is a valid request or not of flight booking request, and then we are doing the mapping to get the flight booking, and then we are persisting this entity inside the flight booking repository. Once this entity is persisted, we are using the beanutil.copy properties to copy the value of flight booking inside the flight booking response, and we are returning this flight booking response. The same flow we are using for hotel booking service. And these are the requests we have seen already, like booking request is a sealed class which will provide permission only for the flight booking request and the hotel booking request. Similarly, we have the booking response which is also using the annotation for seal, and it will permits only the flight booking response and hotel booking response. And the more important is our booking entity. So this booking entity we have defined with the table name as bookings, and we are using the inheritance strategy so that all the three table, we will not want all the three table like booking table, hotel booking table and the flight booking table. Everything will come as a single table, and there is a discriminator column booking type which will help us to identify the different kinds of services, like it's a hotel booking or it's a flight booking. Now let's start our application. As the server is up and running, now let's use this value in our Postman API, right? So the mapping value we can use /v1/API/bookings, and first we will see the example for flight, and then we will see also the example for hotel. So with that we can use the /flight, right? So now inside the Postman API we will provide this URL with http localhost 8080, and we are using post as a request, so we have to provide this as a post. Now here go to the body section, and inside the body section choose the type as raw and the text as JSON. Here if you can see we have different types of text like text, JavaScript and so on. So choose this as a JSON, and here we will provide the request. So our request is composed of two parts, booking request and the flight booking request. So if you see here we have the flight booking request with the flight number. This is the flight number, and we have booking request with remaining details like passenger name, amount and payment mode. Passenger name, payment mode and the amount. I have provided this value as EK402 because in our previous modules of flight service and flight search service we have used this entity. In my next video I will be showing you the microservices communication between different microservices. So for this purpose I am using the same flight number. Now let's run this application by clicking on the send button. So here you can see one booking is created with the ID 1, booking number with the unique ID, passenger name, status, amount and the remaining detail. So let's verify now this detail in MySQL. So in the MySQL, if you see here, we are having a booking DB. So if you go to the application.properties file, here we have defined the database schema as booking DB, right? So the booking DB has been created, and if you notice here inside this entity, we are using the bookings table. So if we go inside this booking table, inside the table section, we can see the bookings is available. Don't get surprised with this two table, booking and bookings. The booking I was using for my previous application, so it is there. So we will be focusing on this bookings. So let's try to run this application. Select start from bookingdb.bookings. And if you run this one, you can see one entry has been created. And you remember this discriminator type. So this discriminator column is flight type. It is showing us the detail with flight. And here if you can see the information is available. And you can notice one more thing here. It is adding additional columns related to hotel booking like check-in date, check-out date and hotel name. As we are not providing this information in the storing perspective, so these details will not be saved. Now let's see the use case for hotel. Okay, so for this thing inside the Postman we will create a post request with the API endpoint as hotel, and here also inside this body we have to add the request and we have to use the type as JSON. So now let's quickly see this 6 values. So inside the booking request, if you go, we have these 3 fields: passenger name, amount and payment mode. And inside the hotel booking request we have hotel name, check-in date and check-out date. So all these 6 details we have provided. Now click on the send button, and you can see here the second record is created successfully. Now let's verify this detail in the Postman. In the SQL. So if we run this query, we can see here the booking type is hotel. And you notice here something, the flight number is not stored in case of hotel, the remaining details are stored like check-in date, check-out date and the hotel name. I hope now it is clear, right? How easily we can use the discriminator identifier based on the flight and hotel, and we can add the specific details related to the flight or the hotel.
In my next video, we will see the microservices communication. So we will communicate with the flight service and also the payment service.